Okay, here's our setup for the lab. Okay, what we have right there is a steam generator. Follows, the steam will come out of that, go into this rod right here. Okay, as it goes through, it will increase in length. That right there measures how much of an increase in length it has. This guy right here measures the temperature, so we can measure the elongation due to the temperature change. Okay, we've got steel, we have copper, and we have aluminum. Okay, so here is the steam generator. Again, it'll come out of the steam will come out of that through this tube, go into the end of this, at which it will travel down and heat this tube up. What we have here is a thermistor. You see I have two cables attached here, a cable attached directly to the rod here, and then that is measuring the resistance of the thermistor. From that resistance, we have this table right here where we can determine what the actual temperature is. So right now we're at about 118,000, and you can see we're, I don't know, somewhere between 21 and 22 degrees Celsius. Okay, as the steam comes through, it will heat up. It'll get close to 100, not quite all the way to 100. Okay, come through the end, come out the steam, and go into that beaker there so we don't make a mess. What we have here is a gauge that'll measure that. So you can zero it like that, and then as this increases in length, watch as I pull on this. Well, let me do it this way with the other hand. As I pull on this, you can see that as it elongates, it actually rotates backwards around. Okay, so we'll get that measurement as it goes backwards. So that's basically the setup. So I'll get the temperature before, get the temperature after, get the length of this rod before, okay, and then get the change in length right from there. From that, I will be able to pull out the coefficient of linear expansion. Okay, we're going to take the measurement first. This is the initial measurement. This is first steel. I'm going to set it on the inside of the thing like that, and then we want to measure to the inside of this pin right here. So I will let you take that measurement. Now for aluminum, okay, again, put that just like that. Now for copper. Okay, we've got steel placed back in there. It's locked over here. I am zeroed out right there for the increase in length. Here is my reading on the kiloohms. So you can, from right here, you can figure out what that is. You can interpolate to get that. So now I've got the steam going. It's tough to see. You'll have to trust me that it's coming out. Okay, pop that on right onto the end there. And again, the steam is going to go all the way through here, come out this side, and in that process, it'll set up kick up the heat as it goes through. Okay. So I'm gonna look here, and you can see the gauge slowly increasing, noticing that it's going backwards. Okay, it's rotating backwards rather than forwards. So as of now, it's gone about, each rotation is 1 millimeter, so it's gone about 4 millimeters right now. Okay, at this point it looks like it's not really moving anymore. Just slide over here. This guy is still dropping a little bit. What I think I'll do is I'll pause just for a second, wait till this completely comes to equilibrium, and then I will show you what the data is. Okay, at this point it's pretty well leveled off. It might still be going a little bit, but again you can see this is going through. I'll get a close-up on the gauge. Remember, this guy moved backwards. It rotated backwards. So when getting that, that is your elongation there. And your final temperature is from that reading. And then using that many kiloohms, I can come over here and calculate through interpolation what the temperature would be in Celsius. Okay, at this point I'm going to set up for the copper rod. Alright, we've got copper in there now. Okay, you can see that I've well, maybe moved a little bit as it cooled down, I think. Here we go. We've got that zeroed out right there. Okay. Here's your kiloohms. So you can read that using that. And that data right there, you should be able to figure out the temperature. And now I've got the initial temperature, the initial length, got my thing. So now I'm going to hook back up my tube here. Just a little hard to do one-handed. Okay. Again, now the steam is going through this guy. And you can see, again, that the displacement is moving backwards on the copper. Okay, one full rotation is 1 millimeter. So it's about half a millimeter right now. Alright, so it looks like it's pretty well slowed down. Again, it'll take a little time to get to equilibrium. You can see that the resistance, the kiloohms, is dropping quite a bit. So I will come back and we can get a final measurement in just a second. Okay, again, we're dealing with copper here. We've pretty much got to equilibrium. Zoom in. You can then measure the deflection. Just given by that right there. Remember, it moved backwards. Your kiloohms on the thermistor is right there. And then you can use that to calculate. Okay, I will be back with aluminum. Okay, so here we've got aluminum. Okay, you can see that I've zeroed out the gauge here. Here is the kiloohms for the temperature. I promise it's more or less steady. I know it just popped up a little bit, huh? We're going to go with it either way. Let's see, now it's going up. Well, we'll take a look at it one last time before I do it. Let me at least show you again where you can, the values you can use to figure this thing out. Okay. And there it goes. I promise it was leveled off before I started the video, but we're maybe just use 107 kiloohms on it. Probably be fine. Just round it like that. So come over here, grab our steam. Got it to 107. Plug this on. Now it's going to change very much. Got all the way up to 107.2. It looks like this is dropping super fast over here. So while this is dropping, notice again it's going backwards. It's already 0.4. But let me talk again about what exactly you need to do with this data. Notice this guy is going all the way around, so it's going more than 1 millimeter. So that's 1 millimeter. It's gone past. I'll let it keep going. I don't think it'll go 2. Again, what we've got here is we've got the temperature before and after from the kiloohms and the chart. We measured the length of each one before. This gauge gives us the change in length, and then from all of that, from the change in temperature, the change in length, I should be able to use a calculation to find out alpha for, again, steel, copper, and now aluminum. Okay, so this guy is more or less steady. We will let it get down to steady state before you take the final reading. Okay, everything's come to equilibrium for the aluminum. Let's go in and take a view. Remember, this guy went all the way around once. Again, it's going backwards. So it's 1 millimeter plus the little bit that we have here. Go ahead and get that. My kiloohms to measure the temperature is given right there. And again, you use this table and convert that to Celsius. Temperature before and after, so we have delta T. We have the original length at the start of the experiment. We have the change in length, the delta L, from that gauge over there. Using all that, we should be able to back out alpha for each of these measurements. Again, we did steel, then we did copper, and this is aluminum. All right, thanks a lot.